Let us continue the next video. Here we spoke about Cartesian plane. Cartesian plane which we are talking about, it is a simple graph sheet, a grid sheet. So first quadrant, x is positive, y is also positive. Second quadrant, x is negative because there is 0, less values are marked over here. So x is negative and y is positive. Here above the 0 is for my y-axis, so it is positive. Then we are going to talk about my third quadrant. Third quadrant, x is negative, less 0, y is also below 0. That is also negative. So quadrant 3 is x negative, y negative. Similarly, if you are talking about the quadrant fourth, the fourth quadrant, the value of x is positive values here. 0, right hand side. So it is positive and y is below 0. It is negative here. So first quadrant and the third quadrant is having the value of x and y is same sign in. That means the first quadrant x is positive, y is also positive, but third quadrant x is negative, y is also negative. The signs are changed in second and fourth quadrant because x is negative, y is positive here. But here in fourth quadrant, x is positive, y is negative. With this understanding, we are going to take you some conceptual tests. The first question, two quadrants where the value of abscissa and are positive, two quadrant where the value of abscissa is positive. Of course, which is in my first and yes, fourth quadrant, super. A simple, a straight line is parallel to x-axis and it is 4 units away from x-axis. The coordinate point of A is, so you can say simple parallel to x-axis. So I'm talking about the parallel to x-axis means x is 0. So I'm talking about either 0, 4 or 0, -4. Both values are possible for coordinate point A. The radius of a circle with center O, that O is taken as origin, is 5 units, then the coordinate point of A, B, C, D. So A is, of course, which is on my x-axis, so 5, 0. And if I'm talking about B value, it is on my y-axis, that is 0, 5. C is -5, 0. And D is 0, -5. Super. The point x, y lies in second quadrant. X is greater than y. Can we justify the answer? Second quadrant means x value is negative and y value is positive. So x is negative here. Negative value is greater than the positive values. Of course, the answer is wrong. The second quadrant, x value is less than y value. Then move on to fifth question. If a point is at a distance of 3 units from x-axis and 5 units from y-axis, then the coordinate point which we are asking about. So listen, a point at a distance of 3 units from x-axis. So x-axis is given here. So from x-axis, that means this is my ordinate point. And the same point is at a distance of 5 units from y-axis. That is, I'm talking about this as a abscissa, right? So we are having the point as 5, 3, or you can write negative 5, 3. Next one is the coordinate point of negative 3, negative 7 lie in which quadrant? It is easy to remember, that is in third quadrant. But the question is to the left side of y-axis, to the right side of x-axis, above the x-axis, all the above. So left to y-axis, right side of x-axis, right side of x-axis, right side of x-axis, no. Above the x-axis, it is positive 1, positive y values or ordinators, positive here. So, but here we are given as negative value. So the right option for this one is to the left side of y-axis. X square is equals to 9. What is the value of x? X is plus r minus 3. Similarly, if I'm talking about y plus 1 is 5, the value of y is 4. The value of x is either positive 3 or negative 3. The value of y is just 4. If the coordinate of 2 points P is negative 2, 3, and Q is negative 3, 5, then we are asking you the calculation here. So simple arithmetic calculation. That is negative 2 is my abscissa. Abscissa of P point is negative 2. So ordinate of ordinate is nothing but yours y-axis. So I'm talking about negative 2, negative 5. That makes me negative 7. The point negative 5, 0 lie on which axis? So it is absolutely on my x-axis. The coordinate point which lies on both x-axis and y-axis. Both x and y coordinate point, only possible one is 0, 0. So next one is a simple games which we can have it along with the students. Material required is Cartesian plane, that is a graph sheet, that is to be well planned with x and y axis to be marked, and this O is also to be marked over here. So we need two colored dies. So one is red color, another one is black in color. Red color is negative values, whereas black is positive value. Can ask the students to bring the grid, yeah, simple Cartesian plane with all the 4 quadrants to be marked properly by 10 by from starting from 0 to 10, both x and y values in positive and negative one. So next one is the player 1 is having all the rights to take red or black. By their own choice, they can take either black or red color dice. They have to throw the die. So once they thrown the dice of red, for example, the red color die is landed as 5. So that means I'm taking negative 5 in x-axis. First throw is on my x-axis. So we can re-insist the students, whatever we are getting as a first one, it is on my x-axis. So second throw, which they can take it as black because already they are taken red. So now they can take as a black die, then it is landed as 2. So the coordinate point is negative 5, 2. So they can mark negative 5, 2. Then the work is to be continued. But here, the player 2 is also to be given one chance at a time for a student. Second player is going to take black as the first one, then red. So black here taken as simple. For an example, I'm taking black as 5. So 5 in black is my positive one. So they will mark very smart. So black color is positive. So positive 5, the next red color is thrown, it is landed as -3. So 5 comma -3 can be plotted over there. So continue the game for 5 minutes. Whoever they are reaching the highest peak or touches x or y axis, then they are the winner for this game. So you can continue for 5 minutes. So it's a simple activity. From this activity, the students can able to understand what is to be marked first, on x-axis or y-axis. Along with that, the quadrant is also to be learned out. So with an easy way of learning the new concept of the students with an activity as a games, which is easy to remember. The next game, which we are going to keep the name as bingo. So you need a pencil, a set of coordinate grids. So coordinate grid, which is I already made it. So before getting into this one, all the teachers are requested to take the coordinate point and mark all the points before giving the instruction to the students. So first rule is, this is a game for entire class. More familiar with coordinate in first quadrant, plotting the point on lines rather than spaces. So each player places 15 crosses on the grid. So the teacher start with the coordinate as 2, 4. So they have to cross and mark a box. So that's why I told you the teachers are supposed to make the proper graph work as an activity before starts, so that you can easily check who's the winner for this game. So continuous 15 coordinate point is to be given to the students. Who is the first winner? That is to be given as a token of love. The grid is more advantage. Use all the 4 quadrant here. So